Assalamualaikum and to all. My name is Muhammad Saiful Aiman from Group F. Today, me and my fellow team members are going to present to you about machine condition monitoring and gear fault diagnostic for gear system. Okay, introduction. A gear is a spinning circular machine that may adjust the powers of speed, torque, and direction. Gear of variety size can change in torque, resulting in a machine advantage and methods to call a basic machine. Two machine gear rotational speed and torque different in proportion to their diameter. So basically, modern machinery will commonly use the gear mechanism in their system. Unfortunately, gear is not a perfect system, but require maintenance support for it to function as intended. This is because in industry, the failure of such critical components result in significant losses. As we can understand, gearing needs to be maintained and monitored closely because of their vital job. Some of the gear can be have can have a fault because of their long usage, and performance is the key for the machine. If the gearing system is not maintained properly, gearing system may lose in performance or value caused by tear and wears. To avoid the problem, many solutions have come up and used to reduce the problem. The most common method used in industry application that is still being used as today is condition-based monitoring system. Condition condition-based monitoring system condition-based monitor is classified as a predictive maintenance technique then continue then that continually monitor the condition of asset using various types of sensor and uses sensor data to monitor asset in real time. With CBM, the gearing can be monitored to identify pattern, apprehend, appreciate, anticipate failure, quantify asset lifespan, and improve safety in manufacturing operation.
Hi, my name is Muhammad Uman Hazib bin Zulkifli, and I'm gonna present about definition. ISO definition is meaning machine condition monitoring and fault diagnostic can be defined as the field of technical activity in which slight physical parameters associated with machinery operation are observed for the purpose of determining machinery integrity. Once the integrity of the machine has been estimated, this information can be used for many different purposes. Next, condition monitoring is the process of monitoring a parameter of condition in machinery, such that a significant change is indicative of developing failure. The ultimate goal is regard to maintenance activity is to schedule only what is needed at any given time, which result is optimum use resource. So next one is BS 38111984 glossary for of maintenance management term in technology condition monitoring. Define the continuous or predictive measurement and interpretation of data to indicate the condition of an item to determine the needed for maintenance. So next, a strategy commonly employed by processing and manufacturing facility to monitor the reliability, availability, and performance of machine. So last is a gear. Gear are defined as a tooth wheel that transmit motion from one shaft to another and determine the speed, torque, and direction of rotation machine element. Gear can be grouped into two major categories: those that operate pair to connect parallel shaft and those that connect non-parallel shaft. That is the definition. Next, I will pass to my group member. Thank you.
Hello, my name is Muhammad Izam. Now I want to present about the measuring method. So, gear vibration monitoring is another application for machine condition monitoring. Impacting and friction can happen in gears, and a single crack in a gear can produce a small change in speed once the damaged teeth are inside the load zone. Impacting will occur, and if there is not enough lubrication for the gear teeth, friction will develop. So, in predictive maintenance, machine vibration monitoring can detect this occurrence of impacting and friction. Although a variety of complex technique can utilize the time waveform, which is amplitude as a function of time, and the frequency spectrum are the two most basic methods for presenting vibration data, which is amplitude as a function of time and the frequency of spectrum. Vibration analysis follows the general flow as described below. Okay, the first step is to calculate the vibration spectrum. Based on the feature of a system, it is possible to model its vibration spectrum. For a given rotating asset, this would include an expected peak at fundamental rotational frequency of the shaft, synchronous speed, which is harmonics, based on additional components like fan blades and gear. In particular, tools can be used to very effectively model expected system behavior. The second method is to establish a baseline. In order to effectively use vibration data for condition monitoring, it is important to establish a baseline. After all, not all vibration is sinister. There are many vibrations that begin in nature and have no impact on lifetime or performance of machinery. A baseline vibration spectrum makes it possible to identify these features. Okay, next is digitize the signal. Vibration data is captured by accelerometers installed on one or more orthogonal axes. The sampling rate of the accelerometers needs to be fast enough to capture the behavior of interest. So next, the signal needs to be digitized at an appropriate sampling rate to enable it to be digitally reconstructed. The result is the time waveform, which is oscillation amplitude as a function of time of vibration along the axis of interest. Okay, the step for number 4 is convert to frequency space. This step is to perform a fast Fourier transform, which is FFT, algorithm to convert the time waveform into a vibration frequency spectrum. The scope of the frequency spectrum depends upon the accelerometers and the analog to digital converter, which is ADC, is used. As discussed above, much of the insight delivered by vibration analysis is based upon correlating frequency spikes to physical characteristics of the system. Okay, the last method is time waveform analysis. So, time waveform analysis can enhance machine vibration analysis. It should not be considered as a primary tool, but rather as a tool provide additional insight. It also can be used for low speed application because it reveals the way the machine is moving. Time waveform analysis is frequently used for analyzing gears, for example. There is a crossover point at around 100 rpm or below that speed. Time waveform analysis provides better results and frequency analysis is not effective. So the graph is show about the frequency graph showing the synchronous vibration peaks.
Okay, Assalamualaikum. My name is Muhammad Ifat. I will explain about why it is important to do monitoring vibration on gear. So, firstly, monitoring vibration on the machine is very important because it will help us to determine the condition of the machine. So, uh, if we don't do the monitoring vibration, it will take a lot of negative feedback or will we will face some bad issue. Example, the first point is accumulation of unfinished goods, which goods that are still being manufactured likely to get stuck at the machine input point. This results in unnecessary waste, wasting time and wasting a good product. So it will cost a lot of money to fix this. And the next slide is unnecessary maintenance. So when we don't do the monitoring vibration on the gear, we will have an unnecessary maintenance. The machine are sometimes shut down unnecessarily to replace parts that are still functional and to solve issues that do not exist that will cost a lot of money and wasting time. Okay, for the next point, why it is important to do monitoring vibration is because occupational hazard that can cause worker employees in danger and human discomfort due to noise and shaking they produce that can become a health issue such as broken bones, problem with nerve system in human body. Okay, we go to the next slide. Okay, for the last point is the quality problem, and I think this is the biggest problem and most problem that many factory in industry that face this problem. Okay, the unmonitoring machine will cause that low quality item, high yield losses, rework cost, or worst of all, warranty return from disgruntled consumer that can uh, give a negative impact to the industry and company.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wilhari Bayud Aziz. My matrix number is P0919103888. To sum up, the diagnosis and prediction of faults can be done in a timely manner by monitoring the change of parameters and studying the physical relationship between parameters and faults. There are so many potential advantages of machine condition monitoring, such as it can increase machine availability, extend the operational life, and improve safety. For the fault diagnosis, it provides the prerequisites for fault tolerance as well as reliability. Next, gears in general provide an excellent example of how machines must wear in during early use. The time waveform and frequency spectrum are the most often used techniques in the industry. This approach makes use of a graph as a reference to detect their fault. Next, the new gears will have defects that they are quickly worn away in the machine's early life. Vibration levels will become steady and only increase gradually later in the machine's life as the gears wear out. These gradual increases in vibration level are normal. Sudden changes in vibration levels at gear mesh frequency, which is 2 times gear mesh frequency, especially decreases, are very significant. Therefore, a drop in the vibration level usually means a decrease in stiffness, and that more of the transmission force are being absorbed due to the bending of the gear tip. That's all from us. Thank you.